Now in this figure we have another technique to visualize the flow. So we have different techniques to have visualization of the movement of fluid particles in different situation of the phenomena. Like here we have another figure in which we want to understand what happens to fluid which is flowing over a square shape. So here we can see these path lines and streak lines if flow is a steady flow. This is done with the help of visualization technique. Now here we have smoke coming out of a stack, and we can see that if we want to model this fluid which is coming out of this stack, we have to define with the help of stream lines, streak lines. This particle is emerging out, and how can we define the path line and streak line? By following each and individual particle over the time. So with the help of this simple visualization technique, we can appreciate that what are the points where we have the attached fluid and what are the points where we have detached fluid. Again, with the help of some visualization technique, we are observing the flow over a cylinder. In this figure, we can easily appreciate as this fluid is approaching towards the cylinder, then up to this point we have fluid which remains attached, and after this point this fluid gets detached, or this boundary layer gets detached. So this is the zone where fluid is not attached with the cylinder. Because of this, we can analyze this phenomena, and if we can suppress the separation of the fluid particles which is happening here in this case, then we can offer the less resistance by the fluid on this cylinder, right. So that's why you might have seen the dimples on the golf ball. These are made because of one reason, that laminar boundary layer is converted into turbulent boundary layer, so that it remain attached to the cylinder, remain attached on this spherical surface. Because of that, the resistance offered by the ball gets reduced, and by virtue of that, with the help of same force, it can travel more distance. Here we have a three-dimensional figure to appreciate the path line, stream line and streak line. Here we have a two-dimensional flow, and a stream line is shown here, and with the help of this stream line we can write down the equation which is dx over u is equal to dv over v. Now here again we have some visualization technique to understand the flow over this flat plate which is kept in this manner, where flow is taking place in x direction. Then what happens to the flow which is approaching? If the velocity of the fluid is very less, in that case this fluid does not get separated here, it is going here, this path line, and again it is coming here, and from here it moves in this direction, right. Again we have another visualization technique to understand the flow this figure we have already seen. In this figure, what is happening? We have made this flow visual with the help of hydrogen bubbles, and what is happening to different particles as fluid is moving in x direction. These particles are getting deformed. They have translation, rotation as well as angular deformation. This is very important figure, as you might have seen the shape of the cars evolving over the time, right? If you see the shape of the car which was made very early and shape of the car which are being made in modern days, their shape is totally different, and it is because of our understanding of the fluid flow, along with as the car speed is going high, we need to reduce the drag, because drag becomes much more predominant as the speed increases. So in this case, we are seeing a model of car being modeled for understanding the flow over the car. So you can visualize that what is happening in the back side. In the back side, you can feel that this fluid is getting separated, and if back shape is not given a proper shape, then more fluid gets separated and this car will experience more drag force. So how can we reduce the drag force? We have to design the front shape as well as the back shape in such a manner so that we can reduce the drag for given shape of the car. So with the help of these figures or videos, we can appreciate the importance of the kinematics chapter